So I want to quickly talk about what an advanced problem may look like on the assessment because we may not end up getting to an advanced problem in class together, but this advanced problem using what you know about linear equations, you should be able to answer this, but we will talk about it here. All right, sorry, just a second. I want to get rid of this shadow. All right, so let's begin. A school district pays an installation fee and a monthly fee for internet service. So if you didn't know what an installation fee is, it's like an upfront payment, um, or you could think of it as like a baseline. Uh, it's a payment that you always have to start with. It's to install something, I guess you'd say. And then a monthly fee. Okay, so you pay this fee, and then every month you pay an additional fee for internet service. The table shows the total cost of internet service for the school district over different numbers of months. So for 2 months of service, it costs the district $5,000, 4 months, $9,000, for 6 months, $13,000, and so on. All right, so A. Can this data be modeled by a linear equation? Explain. If it can, then write a model that represents this data. Okay, so for this to be a linear equation, our rate of change or our slope has to be constant, right? If you think about a line, let's draw it up here. Think about some line on a graph. The slope is constant. The rate of change is constant. This line goes uphill, right, at a constant rate. It doesn't all of a sudden shoot up or shoot down. It's totally straight, going at the same rate. So for this to be linear, it has to create a line, and that means our rate of change has to be constant. So what we can do to see if our rate of change is constant is to find the slope. So what we're going to do is we're going to go from 2 to 4 and from $5,000 to 19 or $9,000 and see if our change from here to here is the same from our change from here to here, then here to here. Okay, so we're going to go and look at each of these changes and make sure we have a constant going on. So from 2 to 4, we add 2. Then from 4 to 6, we add 2. From 6 to 10, we add 4. And from 10 to 12, we add 2. All right, so there's this adding 4 going on in here. But maybe we can see over here what our actual slope is going to look like. So from 5,000 to 9,000, we add 4,000. From 9,000 to 13,000, that would be adding 4,000. From 13,000 to 21,000, that would be adding 8,000. And from 21,000 to 25,000, that is adding 4,000. Now, so when we made this jump with this plus 4 here, that's where we have our jump with our 8,000, which is different. Okay? So if we look at our 4 compared to our 4 is doubled. If we look from our 8,000 and our 4,000, this is also doubled. All right? So I'm thinking that our slope is constant here. But if we look at each of these changes here, this slope from this point to this point would be 4,000, right? Our change in y over 2. And that would be the same for this one and this one, right? 4,000 over 2, 4,000 over 2, 4,000 over 2. But is 8,000 over 4, are they equal? And how can we figure that out? Well, we could divide here, right? 4,000 divided by 2 is 2,000. 8,000 divided by 4 is 2,000. All right. So our slope is consistent. Each slope here is 2,000, right? Our change in y over our change in x. So can this data be modeled by a linear equation? Yes. Explain. We have a constant slope. All right. If it can, then write a model that represents this data. All right. So what that's asking for is a linear equation now. So what model, what form do we want to use? We can use slope-intercept. Okay, for that we would need our slope, which we have, right? This is our slope. And we need our y-intercept. Our y-intercept is where x is 0, but we don't have where x is 0, so that might not be as easy. We could do point slope because we have our slope and we have points. Let's do that. Let's do point slope. So point slope is y minus y1 equals m times x minus x1. So we said our m is 2000, our slope, and then we just need to pick one of these points. So let's just use this point here. My y value would be 5,000, so I do y minus 5,000 equals my slope times x minus my x. All right, that would be a model that represents this data, this linear equation. And we could take this and write this into slope-intercept form if we wanted to, but right now we've got some kind of model that'll work. All right, I'm going to separate my work from my answers here. All right, B. What was the installation fee? Okay, now we need to talk about what installation fee is again. Okay, so installation fee is your upfront fee, your baseline. If you think about what this graph would look like, we were to graph this. Okay, our months are our x, total cost is y. So our cost and number of months. Our installation fee is, sorry, you couldn't see that. Our installation fee is our upfront cost, but we're going to pay no matter how many months. So that is our starting cost. So that means if you think about the way time's moving, it's moving this way because we have a number of months. We have 1 month, 2 months, 3 months, 4 months, 5 months. So our installation fee is going to be at 0 months. Okay, because we're going to pay that right away before we even get the internet pretty much. So if we're starting at 0 months, okay, our installation fee will be our cost right on the y-axis. So what is this point called again? If our line were to go like this, it's our y-intercept, okay? So the installation fee is our y-intercept. All right, how are we going to find our y-intercept? It's going to be kind of tricky. I think what we should do is we can work backwards, right? Let's see, where should I draw this? I could do it right here. So here we have 2 for x and 5,000. Okay, the next line is 4 and 9,000. Okay, so if we said from 2 to 4 you add 2, from 5 to 9 you add 5 or 4,000. Okay, so what if we go back to 0? Because that's plus 2. So if we go back to, okay, well that should be 4,000 here, that changed. So this would be 4,000 less than 5,000, which is 1,000. So our x value is 0, y value is 1,000. So our installation fee is our y-intercept of $1,000. All right, that was B. And then C, what is the monthly service fee? Okay. So that means what that's looking for is, okay, if we start, what additional costs are we going to have each month? All right, well, we know every 2 months we pay $4,000. So what do we pay every month? Well, why don't we just look at our slope? Our slope is our rate of change. Every month, right? Our slope was 2,000. So every month we're paying $2,000. That makes sense because you said every 2 months we're paying 4,000. So our monthly service fee would be $2,000. All right. So hopefully that made sense. We can try to go through some in class together as well.